Hello students, welcome to MEMONEET. I'm Aprajita, your chemistry SME. How are you all doing? I hope everyone is doing good. So today we are back with another lecture. I hope all of your preparation is going well and you have watched the first lecture of coordination compounds. If not yet, so I have posted the first part of coordination compounds yesterday. So please go and watch that. There in the last lecture we talked about the introduction ki what are the coordination compounds. So basically we talked about some important terms that are related to coordination chemistry, like we learned about the coordination entity, we learned about the ligands, oxidation number, coordination number. Okay, many such things we learned yesterday. Then we saw the Werner's theory for coordination compound, where we learned about the primary and the secondary valences, and then we studied the nomenclature, okay, how to name these coordination compounds. So I hope you have practiced some questions. So there are a lot of questions given in the NCERT also. You can practice that, and you can practice the questions on our application also. Okay, on the MEMONEET app, you will be finding this Brahmastra revision patrika. There you will be getting the notes also in chemistry. Points to ponder is there. Okay, so you will be getting all the notes there. And yes, we have NCERT based line by line questions also. Okay, so line by line NCERT feature mein you will be getting questions based on the NCERT, which is important because if you see the last year Neet patterns, so the questions have been asked based on NCERT only. Okay, sometimes so they ask direct question, जो भी example NCERT में दिया है, that same example has been asked in Neet examination. So that is why reading NCERT and solving the questions related to NCERT is very important. So our lectures, the lectures that we are doing also now, they are NCERT based. Okay, so don't worry about that. We are covering all the examples, everything given in the NCERT, but for your revision you need to go through the NCERT also and go through the line by line NCERT feature on the MEMONEET app. Okay, so if you are a Light Plan user, you will be finding this in your application. There you will be getting the questions that are totally NCERT based. Okay, so please make use of all these features that are available to you, because if you do practice side by side now, like if you watched the lecture yesterday, it was a 30-minute lecture, so 30 minutes you can give to practice also, like you can give 1 hour to one subject, right? So you can just practice some questions there. And today we will be learning the next important topic. So today I am just covering isomerism in coordination compounds, because this is important topic here, and I have seen a lot of questions have been asked in Neet from the topic of isomerism also. So today we will be just talking about the isomerism. Then in the next lecture we'll be talking about valence bond theory and crystal field theories. Okay, so in the upcoming lectures we'll talk about that. So today I am just covering the isomerism part. Okay, so let us start. Make sure you are having a notebook and pen with you to understand this topic. Okay, so if I am talking about isomerism in coordination compounds, so we have studied about isomerism many times. What do we mean by isomers? So we actually know that the compounds that have same molecular formula but a different arrangement of atoms and different properties are called isomers. Okay, so molecular formula will be same but the arrangement of atoms or properties would be different, so that we will be calling them as isomers, and this phenomena is known as isomerism. So yes, in coordination compounds also the isomerism is seen. Okay, so there are two types of isomerism that can be seen in coordination compounds. Generally also we have two type of isomerism. First is structural isomerism and second one is stereoisomerism. So you know कि structural isomerism arises due to the difference in structure of coordination compound की formula would be same but the structure would be different. Okay, so that would be structural isomerism. In that we study ionization isomerism, hydration isomerism, linkage isomerism and coordination isomerism. Then stereoisomerism is again very important, which is actually we have studied कि it arises due to different spatial orientation of ligands around the atom. कि in space how the ligands are arranged around the metal ion or the central metal ion. So that will be stereoisomerism. And in stereoisomerism we have two types: geometrical, जिसमें we will study cis trans isomerism, okay, and then we have optical isomerism, where we will be talking about the optical activity, means we'll be talking about chiral compounds and all of that. All right, so this is what we will be learning in today's lecture. So I have taken all these in detail. So let us start with structural isomerism. So as we have already discussed, students, that structural isomerism occurs due to the difference in chemical linkages and distribution of ligands within and outside the coordination sphere. Okay, so basically formula same hoga. Number of atoms you will be seeing, the molecules, you will find same number of atoms. Molecular formula same rahega, but there would be a difference in chemical linkage, ki how those atoms or molecules are linked to your central atom and how the ligands are distributed inside or outside the coordination sphere. So we'll be considering both, right? Inside and outside the coordination sphere as well. All right. So in structural isomerism, isomers possess dissimilar bonding pattern. So bonding pattern kya hoga? That would be dissimilar. Okay. And what are the different types of structural isomerism? Let's see. First is ionization isomerism. Now from the word ionization, you might have got an idea कि we'll be talking about ions. Okay, ionization कब होती है? When you put something in water. Okay, when you actually put it in its aqueous form, then the compound splits up into its ions. Okay, or formation of ions takes place. So that formation of ions is called ionization. Okay. So what happens is कि ionization isomerism, or this is the result of exchange of groups or ions between the coordinating sphere and the ionization sphere. Okay, so you see here this isomerism will occur in the compounds where counter ions act as the potential ligand. So here this is the coordination entity we are having: pentamine, bromo, cobalt 3 sulfate. So this is the compound that we are having. Okay, so this is our coordination sphere, but this is the counter ion that we are having. Sulfate is the counter ion. Okay, now what will happen? Its ionization will happen. So ionization may you will be getting COBr NH3 5. Okay, 2 positive and SO4 2 negative. Now this sulfate ion also has the potential to act as the ligand. Okay, so what will happen? They will exchange. Okay, there will be exchange of ligands that will happen. So sulfate will go inside and bromide will come outside. So you will be getting COSO4, okay, NH3 5 positive and Br negative. So this will happen. Alright, so these two are isomers. So here you were having pentamine bromo cobalt 3 sulfate. Here you have pentamine sulfato cobalt bromide. Formula is same. You can find that formula is same: 5 amine ligands, 1 sulfate, 1 bromine. But it's just that in the first case sulfate is the counter ion and here bromide is the counter ion. So understood ki there will be an exchange, right? Exchange of ions is happening. So counter ion mein yahan fark hai. That's why we will be calling it as ionization isomerism. Okay. So this is the basic idea about the ionization isomerism. नेक्स्ट इज हाइड्रेट आइसोमेरिज्म. इसको हम सॉल्वेट आइसोमेरिज्म भी बोलते हैं. ओके, वी विल बी कॉलिंग इट एज सॉल्वेट आइसोमेरिज्म ऑल्सो. नाउ इन अ कॉम्प्लेक्स कंपाउंड वाटर मॉलिक्यूल बिहेव्स इन टू वेज. ओके, नाउ वाटर कैन बिहेव इन टू वेज. सो वाटर कैन एक्ट एज द लिगेंड and it will be coordinated with the metal atom. Okay, like it is a part of your complex like this MH2OX. Or water can act as the water of crystallization. So you know ki if water is acting as the water of crystallization, it will be outside the coordination sphere. Okay, let's say there is a certain compound MLX and water here will be acting as the water of crystallization. So there are two ways in which water molecules can attach to these compounds. Okay. So this isomerism, you might have got an idea that it occurs due to dissimilar number of water molecules as ligands inside the sphere and as water of crystallization outside the sphere. So we will be calling it as hydrate or solvate isomerism. Okay. So this is analogous to your ionization one only, क्योंकि ionization में भी हमने क्या पढ़ा था that the ligands inside and outside the sphere are getting exchanged. Here it's just that there are not normal ligands, these are just water molecules inside the and outside the coordination sphere which are exchanged. Here you can see this is the compound CrH2O 6Cl3. Now it has three possible structure ki all the water molecules are acting as the ligand and chlorine is outside the coordination sphere, so it has a violet color. Then we have one water molecule can go outside as water of crystallization. Okay, 5 there remains there, so it's green. And then if you have two water molecules which are outside the coordination sphere, okay, so that will be dark green in color. So the main thing is that these compounds differ from one another with respect to the water molecules acting as ligands. Ki number of water molecules inside and outside the coordination sphere would be different. Okay. So that is the thing. Next is linkage or salt isomerism. Now what is this linkage? So linkage isomerism occurs in complex having ambidentate ligand. So just yesterday we studied what are ambidentate ligand, which can combine with the metal atom through more than one atom, right? Like देखो यहाँ पे like cyanide है तो C triple bond N. It can combine through carbon also, okay, or it can combine through nitrogen also, like NC. Then NO2, and so it can combine to ONO, like this is there. So these are the ambidentate ligands. So in this isomerism, ambidentate ligand will coordinate with different atoms, and these are differentiated by infrared spectroscopy. Spectroscopy you will study in higher classes, don't worry about that. For example, यहाँ पर देखो we are having nitro NO2. So this is pentamine nitro cobalt 3 chloride. So here the linkage has been happened through the nitrogen. Okay, nitrogen से linkage हुई है. But here the linkage has happened through oxygen. So when this ONO is there, we will be calling it as nitrito. So it becomes pentamine nitrito cobalt 2 chloride. So it is yellowish red in color and here it is red in color. So this is the difference in linkage. Linkage means they differ in the linkage of atoms. यहाँ पर linkage nitrogen से है and here the linkage is through oxygen. Okay. So you can see the difference ki A is not decomposed by the action of acids but B liberates HNO3 by action of acid. Okay. And there are different examples also. यहाँ पर देखो thiocyanate SCN is there. So here it's NCS. Again here NO2 and ONO, nitro and nitrito. So these are the differences between the these are the main examples for the linkage isomerism. The fourth one is coordination isomerism. So coordination isomerism कहाँ पर होगा? Where we have both cation and anion as complex. Okay, cation भी हो, anion भी हो as complex. So there will be an exchange of ligands between the cation and anion. Simple, there will be exchange of ligands between cation and anion. Okay. So here it can also occur in those complexes where both cation and anion have same metal atom. Like here you can see that cation and anion both are having chromium. So there will be exchange of ligands. Okay, exchange of ligands hoga. So 2 thiocyanate has come here and 2 ammonia has gone to the anion part. So there will be an exchange between the cation and the anion. So this we will be calling as coordination isomerism. So basically you need to understand the difference between all these isomers. Okay, so they can give you examples and they can ask you what kind of isomer it is. Okay, or this compound will show which type of isomerism. So ऐसे questions भी आ सकते हैं in NEET. So knowledge of isomers should be there. All right. Now let us talk about next type of isomerism. that is stereoisomerism. Again, very important. So we have discussed that stereoisomerism arises because of the different arrangement of ligands around the central metal atom in space, ki how the ligands are arranged around the central metal atom. So there are two types: geometrical isomerism and optical isomerism. Okay, geometrical isomerism is important because a lot of questions are asked based on this. So you need to understand which kind of compounds will show the geometrical isomerism and which will not. So you know ki isomerism or isomers which arises due to different relative arrangement of ligands around the central metal atom is called geometrical isomerism. Okay, so they are of two types, cis and trans. Okay, तो cis isomerism में क्या होता है, there are similar groups which are attached adjacent to each other, and in trans isomers the similar kind of groups will be opposite to each other. Okay, we will see some examples related to it. So see, the compounds with coordination number 4 and 6 mainly, they show this geometrical isomerism. So let's see the geometrical isomerism with coordination number 4. Okay, so coordination number 4 में you can have tetrahedral complexes or you can have square planar complexes, right? So you know the difference between tetrahedral and square planar. We have studied it in chemical bonding. So tetrahedral complexes will not show geometrical isomerism as all the four valences are identical. Okay, जो चारों position होती हैं वो identical होती हैं in space. So tetrahedral complexes, they will not show geometrical isomerism. Square planar complexes will show. And square planar complexes में भी कौन कौन से compound show नहीं करते. Let's see. First is the complex of type Ma4. Ma4 means where all the four ligands are same. अब चारों लिगेंड यहाँ पर जब सेम है तो कैन यू ड्रॉ सिस और ट्रांस आइसोमर्स फॉर इट? नो, राइट, बिकॉज कोई डिफरेंस ही नहीं है लिगेंड में, सो दैट कैन नॉट बी देयर. देन द कॉम्प्लेक्स ऑफ टाइप Ma3b. अब A3B भी नहीं शो करेगा क्योंकि तीन लिगेंड एक जैसे हैं. एटलीस्ट दो लिगेंड्स जो हैं वो अलग होने चाहिए. ओके, देयर शुड बी टू डिफरेंट लिगेंड्स, तब हम उनकी पोजीशन. सो Ma3b और MAB3, any of it, these compounds, these type of coordination compounds will not show geometrical isomerism. A और B monodentate ligands होने चाहिए यहाँ पर. Okay, with denticity 1. Okay, so these will not show because you cannot draw only the isomers for it, because at least 3 ligands जो यहाँ पर same है, at least 2 अलग होने चाहिए, then you can draw. So we can draw the isomers for Ma2B2 and Ma2BC types. Okay, कैसे कर सकते हैं? Let us see that. So Ma2B2 की अगर हम बात करें, okay, Ma2B2 की अगर हम बात करें, if the two ligands are adjacent like this, okay, ऐसे अरेंज हो सकते हैं, या they can be arranged like this, A opposite to A and B opposite to B. So this form, the first one, will be known as the cis form. Okay, and here the two A ligands are opposite to each other, so this will be the trans form. So यहाँ पर at least two ligands were different, so we can show this isomerism. So the example is PTCl2 NH3 twice. So you know, if two chlorines are present on the same side, so and two ammonia on the same side, so this is the cis form, and this one is the trans form. All right, so this is how you can draw this. All right students, so same goes with Ma2BC. अब यहाँ पर दो ligands at least same है. All right, so PTCl and pyridine is there ना. So if two pyridine are on the same side, see, two pyridine are on the same side, one chlorine and one ammonia, ये कोई भी position हो सकती है, doesn't matter, so it will be cis form. And if two pyridine are on opposite sides like this, PY and PY, and यहाँ पर chlorine and NH3, so it will be trans form. All right, so that will be the trans form. So this is of type Ma2BC कि at least two ligands are same, other two ligands are different. और यहाँ पर Ma2B2, these are the example for square planar complexes, how they show cis trans isomerism. Okay, I hope this one is clear. Now if I talk about MABCD, so you know this also shows isomerism, means चारों के चारों ligands अलग हैं. तो here you can tell कि you can fix one. अब A को fix कर दिया, अब क्या करो, B को इसके trans रख दो, C and D. Okay, similarly MA, अब C को यहाँ रख दो, okay, opposite to A. अब ये देखो A और D, they are on the same side ना, this is the cis form if I can compare it with A and D. Okay, ये दो cis form हो जाएंगी if I am talking about A and D only. Okay, now you can put अब A तो फिक्स था ही, now B and C हमने उसके ट्रांस रखा, now put D trans to it. अब B और C, but what can happen is trans में अब मैं D trans रख रही हूँ तो C यहाँ आ सकता है, B यहाँ आ सकता है, but these two are same. Okay, so this is the trans form. So actually there are 3 isomeric form, 2 cis and 1 trans. Okay, if I consider any 2 ligand, you can consider any 2 ligands. Okay, तो एक को fix कर दो and put other ligands trans to it, so वहां से आपके isomers बन जाएंगे. Okay, so if A I am talking about with respect to A and D here. All right, so this was about the square planar complexes. Now if I am talking about coordination number 6, so generally these are the octahedral complexes. Okay, octahedral होंगे. अब octahedral में again at least 2 different ligands should be there. So Ma6 कि अगर 6 के 6 ligand same है, if all the 6 ligands are same, so you cannot talk about cis or trans isomerism. Same goes with Ma5B. अब 5 है हमारे पास A, okay, and 1 is B. So you cannot just show any cis or trans. So these compounds will not show cis trans isomerism. Now you can talk about Ma4B2. Okay, Ma4B2 और Ma4BC same रहेगा. Okay, so they can exist in 2 cis like 2 trans your isomeric forms. So let me erase this. So the example is COCl2 NH3 4. Okay, so how you can draw this one? See, अब cis form क्या होती है, ये आपके दो तरह के bonds होते हैं. All right, so अगर ये दो positions है, ये दो adjacent positions है, same group occupy कर रहा है, तो this is cis form and this one will be trans form. So if 2 different forms they are occupying this axial position, okay, so we'll call it as trans. एक axial एक equatorial है, so that will be cis. So if I am talking about, see, 2 chlorine are there, so 2 chlorine, now they are adjacent, okay, and rest will be your ammonia ligands because 2 chlorine are there, right? So this is the cis form. And trans form क्या होगी students? You can draw it very easily. 2 chlorine will be opposite to each other. That's what we have been discussing, and rest 4 positions will be occupied by the ammonia ligands. So this will be your trans form. Okay, so this is the trans form that we are having. Fine. तो A4B2 और ऐसे A4BC भी हो सकता है. BC means these two groups can be different also. 4 एक जैसे, 2 अलग अलग, तो वो जो 2 अलग अलग हैं यहाँ पर होंगे like chlorine और NO2 if I write. So if they are opposite, so that will be trans. All right. Next, A3B3. Now this is again very important. Okay, facial and meridional forms. A3B3, अब 3 ligands अगर same है, so octahedral में you know that they form this octahedron, right? If we 3D में देखें, so they will form octahedron. Now there are 2 forms, facial and meridional. तो 3 ligands same तरह के होंगे. अब वो 3 ligand अगर ऐसे arranged हैं that they form one triangular face of the octahedron, so then that will be the facial isomer. Okay, देखो यहाँ पर, this is like this. Okay, so ये triangular face एक बनता है, this is the triangular face. So 3B, the similar groups are forming this thing. All right, so this is one triangular face of the octahedron. So this is the cis isomer, or you can say the facial isomer. And then if the 3 groups they are present differently like this. So they are at meridional position, so we will be calling them as meridional isomer or the trans isomer. Okay, so for A3B3 type this exists. Okay students. Now if you have a complex with all the 6 different ligands, so it can exist in 15 isomeric forms. We don't have to draw all of this, and only one compound of this type is identified. So it is easy, you can remember platinum, then we have bromine, chlorine, iodine, nitro, NH3 and pyridine. So this will show 15 isomeric forms. Then one more can happen students, AB3. Up till now we were discussing monodentate ligand. So now if it is a bidentate ligand, okay, just like we have ethylene diamine. If we have ethylene diamine, so they can also show cis and trans forms. Okay, so देखो, here you again have these BB groups, V, all right, and these are A. Alright, अब यहाँ पर देखो जो A and A है, they are opposite to each other. If they are opposite to each other, so that will be your trans form. Okay. Then again, if I am talking about bidentate ligands, MAA2 type, alright. So they will also exhibit geometrical isomer where A is a symmetric bidentate ligand. For example, ethylene diamine. यहाँ पर जो था ना, it was AB, so it was unsymmetric. So ethylene diamine unsymmetric में नहीं आएगा here, alright, because it's AB ना, तो यहाँ पर दोनों atoms अलग अलग होने चाहिए, donor atoms. ethylene diamine में same है, यहाँ पर दोनों atoms अलग अलग होंगे. So this type of isomerism can happen. And इधर we have symmetrical bidentate ligand like ethylene diamine, oxalate. So here this is an example, COCl2 En twice positive. Okay, so how it can happen? अब देखो, we have 2 chlorine and 2 ethylene diamine. Okay, so if 2 ethylene diamine are adjacent, so यहाँ से पहले we will draw 6 bonds. So this is one ethylene diamine En and this one is another. Okay, see, these are adjacent to each other, and other two will be chlorine. So this is your cis form. And transform क्या होगी? When these groups are opposite like this. अब opposite कैसे होंगे? Here you will be having ethylene diamine groups and chlorine, you can see they are trans to each other. So this is the trans isomer. So you can draw these examples also side by side. So this is how we can draw the isomers. Okay, and you can see another one also. So cobalt ethylene diamine, again it's here, but यहाँ पर वहाँ पर दोनों ligands chlorine थे, here it is different. Okay, so it's BC type like this. Here it was MAA twice B2, MAA twice BC type है ये. Okay, now you can see here these are the 2 ethylene diamine group. This is cis form and this one is your trans form. Okay. Now let's talk about optical isomerism. So you know optical activities means the compounds which rotate the plane of polarized light, that are optically active. If the plane rotates clockwise, we call it as dextrorotatory or D form, and if the plane rotates anti-clockwise, we call it to be levorotatory or L form. Okay, so optical isomers will differ in optical properties. So basically optical isomers क्या होते हैं students? So optical isomers are actually the mirror images that cannot be superimposed on each other, means they are non-superimposable mirror images, and we call them as enantiomers. Okay, so this we will study more in organic chemistry. We will be talking about optical activity and all of that. So just try to understand the molecules that cannot be superimposed are called chiral. Okay, so here you can see this compound, this is the mirror image. Okay, and the mirror image is non superimposable, मतलब if अगर आप इसको इसके ऊपर रखेंगे, so it is non superimposable. So these two forms are dextro and levorotatory. So here optical isomer can be seen in octahedral complexes having didentate or bidentate ligand. So here you can see we have ethylene diamine, 3 ligands are there. So this is the dextro form, and if I rotate it, means the mirror image, this is the levo form. Okay, so in tetrahedral or complexes, it is not seen in even in square planar also there is plane of symmetry, and because of plane of symmetry chirality nahi hogi. Okay, so there will not be any optical isomerism. Here you can see optical isomer of cis PTCl2 En2. So only the cis form here will show the optical isomer. क्योंकि अगर आप इसकी transform draw करेंगे, see this is the cis form ना, let me draw the transform like this. Okay, PTCl2 En and here also En. Okay, so this transform you can see it is actually symmetric. Okay, it has a plane of symmetry, this one is symmetric. So अगर आप इसकी mirror image पे बनाएंगे, so that will be superimposable, so that will not be a chiral molecule. So only cis form here is showing the optical activity. Okay, so this was regarding the optical isomerism. Okay students, so this was regarding isomerism in coordination compounds, where we have studied about structural and stereoisomerism. Main focus was on cis-trans isomerism. So try to recall all these concepts, go through the NCERT and solve some questions as well. Like I have told you earlier also, from the MEMONEET app, try to solve the questions on particular topic daily basis. Okay, whatever video you see, try to solve the questions immediately for that. All right. So, and in the next video we will be talking about the bonding in coordination compounds, ki how the bonding happens. All right, so we will be talking about the valence bond theory. So don't forget to watch the next lecture as well, and if in case you are having any doubts, please to comment below and also tell me whether you are understanding the things or not. So see you in the next lecture students. Thank you. Bye bye.